Okay, so we have successfully made it through our first lesson using flipped classroom, listening to the recordings on your own, at your own pace, doing whatever you need to in order to get all of the information, again, at your own pace. And so now we are going to continue on with the next lesson in our unit on applying properties of rational exponents. So think back to the beginning of chapter 2 where we learned or reviewed the properties of exponents. At that time, our exponents were integers. Now we're going to be looking at the same rules, but with them being rational exponents, so in the form of a fraction. So for this next slide, again, you don't really need to copy it down if you have a good idea about the rules, about the properties. But if you're still kind of like, I'm not really sure why she's doing it this way, you may want to go ahead and copy down some of these examples. So if that's the case, again, pause, copy down what you need to, and then when you're ready, press play and begin again. So for those of us that are ready to move on, like myself, let's go ahead and take a look at the next slide. All right, so how are we going to use these properties? So we have a couple of examples here. Now I might show you some different tricks than what the textbook shows you, but again, taking a look at the textbook, taking a look at these lessons, you decide what works best for you. So we're going to come over here, use the pen. So for the first question, we have 8 squared times 3 squared, and all of that is being taken to the negative 1/2. Well, the first thing I want to do is get rid of that negative. So I'm going to follow the rule that says if I have a negative exponent, I need to put it into a fraction. I'm going to basically invert it. So this whole thing, I'm going to put the multiplication sign in there. It makes me a little more comfortable. So now I have a positive exponent. Then I'm going to go ahead and distribute that 1/2 exponent. So I have 8 squared taken to the 1/2, and I have 3 squared taken to the 1/2. Let's continue this little rational bar there. So 2 times 1/2, of course, is 1. So this is 1/8. And then 2 times 1/2 is 1, so 3 over here. And then continue to simplify this, it would be 1/24. Again, unless we need to, don't put it in a decimal form unless the instructions tell you to put it in decimal form, rounding to the nearest hundredths place to 2 decimal places, or it's a word problem. If it tells you to simplify, then it wants it to be in rational form. So if your answer is not a whole number, then go ahead and keep it in that fraction form. All right, part 2. We have 4 to the 1/5 times 2 to the 1/5, and all of that is being taken to the 10th power. So again, using our power of powers rule, we're going to distribute that 10 to both parts of our product here. So 1/5 times 10 times 2 to the 1/5 times 10. Now power of powder, we multiply the powers. So 1/5 times 10 would be 10/5, so that's 2. So this becomes 4 squared. And same thing here, 1/5 times 10 is 10/5, so that's 2, so this is 2 squared. So then 4 squared is 16, 2 squared is 4, multiply that together, and you get 64 as your final answer. All right, example C, we have 3 parts going on here. So first thing I want to do is go ahead and simplify this rational division problem here. So I'm going to subtract the exponents. So this is 5 to the 3/4 minus 1/2. Now 1/2 is also the same as 2/4. So 3/4 minus 2/4 would give us 1/4. And then we are going to square that, or multiply it by 5 squared. So then we have 1/4 plus 2. Now, if I'm adding, again, I want rational exponents. I don't put them as mixed numbers. I put them as improper fractions. So I'm going to make 2 into an improper fraction of 8/4. So so that when I add it, I get 5 to the 9/4. Instead of saying 5 to the 2 1/4, all right, you're never going to see exponents written like that. That's awkward. So put it as a rational exponent. Put it in that fraction form. Again, pause, rewind, review these lessons as necessary as we continue on. Example 2. We're going to be using our properties of radicals. So think back to when we were simplifying our square root signs. So we've started off with a nice basic square root sign. Now my strategy when I simplify radicals is I can go ahead and use prime factorization. Oops. Let's redo that part. Let's get into the pen. Makes it a little bit easier to actually write. So I'm going to go ahead and combine this all together. Basically it's the same as saying 8 times 50. And I'm going to factor it all out. Get into the prime factorization. So 8 is 2 times 4, and then we have 2 times 2. So this is 2 times 2 times 2. 50, of course, is 2 times 25, and then 25 factors to 5 times 5. So we have 2 times 5 times 5. Now when we're taking the square root of something, we're looking for 2 numbers, so we circle our pairs. If I were taking the cube root, then I would look for 3 numbers. If I were taking the 4th root, I would look for 4 numbers. But right now we're looking for the square roots, we just want 2 numbers. So everything pairs up nicely, so that all comes out of the radical sign. Nothing's left in on the inside, so I'm just going to multiply what we had together, and that becomes our simplified answer. Now you could go on ahead and from this step up here of 8 times 50 and said the square root of 400. Now if you remember that that's a perfect square, then of course you can get straight to 20. But when you're simplifying your radicals, you need to show your work. So I think a foolproof method is using the prime factorization. All right, for part B, let's go ahead and try and simplify what's going on here first. We have the cube root of 192 divided by the cube root of 24. Well, one thing we would try first is to see if we can divide 192 by 24 to get a whole number, to get a nice integer. Then I can factor that. If not, if it doesn't divide easily, it can at least simplify, and then we would go from there. But fortunately for us, 192 divided by 24 is equal to 8. And if you don't already know, you can use prime factorization, factor out 8, and look, we have 3 2's, and since I'm looking for the cube root, that's perfect. The cube root would be simplified down to 2. Alright, and moving on to our third example. And this will finish it up for us for part 1. Don't want to put too much on at one time. So example 3, writing radicals in simplest form. So example A shows us asking for the 5th root of 64. Now, when we simplify using prime factorization, 64 is 2 times 2 times 2 times 2 times 2 times 2. There are 6 2's, but I want the 5th root. So that means I'm going to pair or circle up 5 of them, and I have 1 left over. So these 5 come outside of that radical sign, and then that 2 is left over on the inside. But be careful, don't leave it at just this. Remember, this is a 5th root, so you need to have a little 5 in there on the radical sign. So make sure you're writing neatly. On the whiteboard, it's a little bit hard to do, but of course with your pencil and paper, it should be fairly easy. Also remember that in simplest form, we can't have any radical signs in the denominator. So when I'm looking at example B, I know that 4 only has 2 factors, or 2 2's. So I need to basically think to myself, what can I multiply this by in order to have a 3rd 2? So I'm going to multiply by the cube root of 2 over the cube root of 2. This whole thing right here equals 1. And what that gives me is now I have 3 2's in my denominator. If you want, you can always bring that together to simplify. So I have 3 times 2 up here, and then I have 2 times 2 times 2 down here. So these three 2's here will come out of the radical sign. So now we have no radical in our denominator, and we just need to simplify the numerator. So now we're at the cube root of 6 divided by 2. All right, if you need to, go back through any of these examples, revisit them. If you're ready to move on, look at example or part 2 of lesson 3.2.